Now we come to Tycho Brahe. But first we remember that this is a time when knowledge was starting to travel the world. Here we can see again the voyages of Drake and Magellan, shortening the distances between continents, carrying knowledge and information, slowly, but across the world, shrinking the world in a sense, and so benefiting the spread of ideas. The best ideas could succeed by passing around different cultures and traditions and being communicated. The idea of scientists writing letters to each other, even if the correspondence took many months, started in this time. And the figure of this time we talk about now is Tycho Brahe, who lived from 1546 to 1601. He has an extraordinary life story that's worth mentioning a little bit. It was a rags to riches story. He was born essentially into poverty, but got lucky and fell into the lap of comfort with an aristocratic Danish family. Essentially, his uncle was wealthy and childless. His father had far too many children to support, and his uncle wanted a male heir. So Brahe's father sold Brahe to his uncle, and with this simple transaction, Brahe went from poverty to aristocracy. He lived with his uncle educated him, he made the round of universities, studying at Leipzig, Wittenberg, Rostock, Basel, Augsburg. He was also voraciously interested in many subjects, and he had intended to study law, nudged by his uncle in fact, but he was drawn to astronomy. He was a tempestuous and hot-headed man, and we can see in this picture and later pictures a metallic nose at the tip of his nose. He lost part of his nose in a duel at age 21 in 1566, not over anything dramatic or another woman, but over who was better mathematician. We also know that Brahe was ripped off essentially with his nose because he thought he had a silver nose, but when his body was exhumed, it was shown by the corrosion that he got sold a dull alloy instead of pure silver. By 1561, he'd viewed his first solar eclipse at the age of 14, using ephemerides that he'd obtained from other sources. And 2 years later, he observed a conjunction of Jupiter and Saturn. And he noticed that the tables, the Alphonsine tables that had been used by astronomers for centuries, were off by a month, and that the better later tables were out by days. He took the challenge of doing better, of actually measuring planetary positions and stellar positions better than anyone had done before. In 1572, he observed a guest star, or a supernova, in Cassiopeia. We know it as Supernova Cas A. The new star did not move in the sky, so he knew it wasn't a comet. It was remarkably bright, brighter than Venus and visible for a few weeks during the day. Limits on parallax put it further than the moon. And so he showed that this was an object in the distant celestial sphere that was not static, whereas Aristotle had said the fixed stars were perfect and pure and unchanging. So this cast doubts immediately on a part of Aristotle's cosmology. Then, 5 years later, he observed a famous comet, which was also as bright as Venus and had a 22-degree tail. That's a very large tail covering almost a quarter of the sky. He was the first to compute its trajectory with careful observation, and he was able to conclude that it must have crossed the sphere of Venus. And that once again showed something about Aristotle's cosmology was wrong. How could there be these crystalline spheres if there were transient objects that crossed the spheres on strange orbits that couldn't be spherical and centered on the Earth? So with his careful and meticulous observations, Brahe was deconstructing Aristotle's ideas of the universe. He had another stroke of luck. Having vaulted into the aristocracy, he and his uncle were traveling in a coach after a heavy storm. Just ahead of them, the king of Denmark had been going over a bridge which was eroded by the rapid river underneath, and the bridge gave way, and the king's coach was tilted into the river, where he would have drowned if Brahe and his uncle had not happened upon him. Rescued by Brahe and his uncle, and impressed by his intellect, King Frederick II of Denmark offered him an entire island and generous support to build an observatory, we calculate the amount of support he was given at about 1% of Denmark's GDP of those times. He was set. For the next few decades, Tycho worked on Uraniborg, that is Urania's castle, a major astronomical institute that he built from scratch. It had farms to support it, a paper mill, a print shop, an extensive staff. It attracted many expert observers from other parts of Europe. And because of the complicated machinery which had to be tended underneath and calibrated underneath in small crawl spaces, he actually hired an army of little people, or dwarfs, as helpers. And for a strange reason that we don't really understand, he kept a pet GNU. Finding that wind disturbed his observations, he built a second observatory, and he put the instruments below ground on bedrock. He was always improving his methods. He was meticulous. He invented and constructed dozens of improved instruments. He initiated the practice of quoting measurement uncertainties, and he determined very accurate corrections for atmospheric refraction, which is the bending of light from a celestial object as it approaches the horizon. In all of this, he was very careful, wrote everything down, and he gained, even though he didn't have super high accuracy because he had no telescope, he gained by multiple measurements. By making 2 decades of careful observations of the same phenomena, he was able to make extraordinary progress. Here we see a picture of the island of Hven. And here we see his island up close. I went to a conference there about 15 years ago. There's relics of his observatory there. It's a beautiful little island, currently owned by Sweden. Here's Uraniborg. Here's an aerial view with the gardens and the palace. It was a wonderful place to do your observations. And it was a center of astronomy in Europe at the time, because Brahe was essentially the court astronomer of the King of Denmark. He didn't like distractions in his work, though. He was an obsessive worker. We might say he would be OCD if we had him around today. His quest for accuracy did lead to these technical advances. He used mechanical clocks to time his observations. He had multi-user instruments so that multiple people were making observations from different sight lines at the same time, letting them measure different and new things. His instruments were large, but unlike the Islamic astronomers who just made them so big they didn't really work very well, they settled under their own weight or on their foundations, his instruments were beautifully built from strong materials. They were well maintained and continuously calibrated against each other, so if any one of them had a problem, he would know about it. When he published his observations, Tycho would include engravings of his instruments, along with instructions in their use. And this is really one of the first examples of experimental science in a published form. He also invented his own cosmology, and in this he didn't really make any useful innovation. His first system of the universe had the sun and the moon revolve around the Earth, and the other planets revolve around the sun. So this is sort of a kludge, or a hybrid, of the Ptolemaic system and the Copernican system. Why did Tycho choose this when he knew about Copernicus's alternate choice? Well, lacking a measurable parallax for the stars, he didn't really have a firm experimental basis for choosing. He rejected Aristotle's spheres. We've seen that he rejected some of Aristotle's physics, but this allowed him to be more conservative in other ways, because I think he was a deeply conservative person. So his system is really a geometric compromise, keeping the Earth at the center and avoiding a conflict with the Church. And this raises a question in the history and philosophy of science. How do you choose between theories? Tycho knew that from a mathematical perspective, all 3 systems were identical: a completely geocentric system, a completely heliocentric system, and Tycho's system, which was a coordinate transformation from Copernicus, sort of a hybrid of the two. The one key observation that might distinguish between them was inconclusive. So all 3 models are equally effective at preserving the phenomena, or explaining it. They're equally simple, although perhaps not in detail, and they're equally explanatory, or useful in terms of finding where a star or planet might be on any given day. The argument seems to be the relative simplicity of the cartoon version, which is to say the heliocentric model. Astronomy is still running up against this central question. What does it mean for a theory to be true? Now our questions, of course, are more audacious about the size of the universe, or whether there was something before the Big Bang, or how all the laws of nature are unified on string theory scales. But it's still a question we ask all the time. Do the scientific theories themselves carry implications for the reality of the entities they describe? You'll recognize this as one of the most profound and important questions that the Greek philosophers posed originally. It's a central argument of 20th century philosophy of science. In the 19th century view of practicing scientists, there was a principle called Occam's razor, after William of Ockham, a nobleman in England in the 14th century. Occam's razor says, all things being equal, the simplest solution tends to be the best one. So we should always choose the simplest theory, which is the one that doesn't conflict with experiment. But why should nature be simple? Why should we choose the simplest theory? Because it's easiest for us, easier to calculate, easier to explain to someone else? That doesn't necessarily mean that it's true. Karl Popper in the 20th century said that theories can only be falsified, they can never be verified. Experiment has the final word. Given two theories, which are experimentally equivalent, we choose the one with the greatest data content that matches the best against the most data. Thomas Kuhn had a more pragmatic view and said, pick the theory that's most useful. And another philosopher of science from the 1970s and 80s, Paul Feyerabend, is a more radical revisionist view, which says that there's no real method of science at all, and there's no rational method of choosing between theories, that the scientific method does not have a monopoly on truth, and that heroes of science, as we worship them in courses like this, in fact rely on whims and rhetoric and tricks, sleights of hand. Maybe a strict set of rules would stifle scientific progress. This is a view that's pretty uncomfortable to most practicing scientists, but Feyerabend has a point of view that should be listened to as well. As we get to Tycho's later life, we find his epic, larger-than-life persona continues. Christian IV, the successor to Tycho's patron, Frederick II, matured, and it was clear that the expense of Tycho's, not just his island and all the staff and all the expenses, 1% of GDP, but also he had very expensive tastes. He was a bit of a party animal. And so Christian IV was more conservative, not interested in astronomy, and made it clear that he wouldn't continue support for Brahe and for his island observatory. Tycho then, pragmatically, dedicated his 1598 book to Emperor Rudolf II in Prague, in an attempt to find somewhere else to go and hang out. And eventually he did move out of Ven, and with his enormous entourage moved to Benátky Castle in Bohemia, under the patronage of Rudolf, to set up a new observatory in 1599. A year after that, he took on the young German astronomer Johannes Kepler, who inherited his data and passes on us to the next stage in the story. We'll learn that these two people needed each other. He died with little warning in October 1601, having made little progress in the last few years. His epitaph says, "Neither wealth nor power remain, only the arts and the sciences." And as always with Brahe, there's an epic story that goes with his demise. As it's told, he was dining with his patron in the castle in Bohemia with a lot of rich people. Brahe liked to drink, and he'd drunk his fill and was extremely full to bursting, literally. But by the tradition of the day, you would never take your leave until your host got up. And so increasingly uncomfortable, Brahe just sat at the table, waiting till he was able to leave. When he finally was able to leave, he rushed to his carriage and went down the hill, and on the hard stone cobbles, jostling in the carriage, his spleen ruptured, and he died of an infection 3 days later. Luckily, for the history of astronomy, he had already given his data over to Johannes Kepler, who was able to take the next step. And that's the end of this topic.